Hello and welcome to this short reviewing clip of acids, bases and salts, and we'll also use ionic equations as an example of how these reactions can be illustrated more clearly. Obviously, as always, the clip needs to be used after your independent study and notes on this topic have been done. So by now you should have the definitions for acid, base and salt in your notes, so I'm not going to refer to them too much during the course of the clip, but I'll leave them up there on the screen as reference throughout. Now there's a few equations that you must learn and memorise because if you're not comfortable with these equations and don't have them at your fingertips, you'll find work on acids and bases and salts quite tricky to get right. So like I've just mentioned, it's absolutely essential to know these, otherwise you'll struggle to construct balanced equations in any exam questions that involve acid, base and salt type reactions. You'll need to be able to apply them also to all the group 1, 2 and 3 metals, taking into account the charges on the metal ions. So it goes without saying that you need to be comfortable with all these ions, equations and formulae secure in your mind, because they all can be applied at some point across to these equations that you need to learn to memorise. So when we start talking about neutralisation, we need to bring in another term, and that is alkali. Sometimes alkalis and bases get confused in people's minds, and it's important to try and separate them out because there's a subtle difference between the two. The easiest way to remember it is to have a Venn diagram where you have all bases, and within all bases you have a further subclassification called alkalis. So all alkalis will by definition be bases, but not all bases by definition will be alkalis. So if we now look at some of the examples of each classification, you can see that although soluble hydroxides would be alkalis, you'd also get in the bases category ammonia, all carbonates and hydrogen carbonates, and another classification of an organic compound that is basic that we'll talk about in year 2, which is amines. So it's important not to forget during neutralisation that if the acid is reacting and behaving as an acid, it's releasing H+ ions. A salt is being formed when those hydrogen ions in that acid are being replaced. You have to think about where those hydrogen ions go. They end up as water. So it's important to remember that as well. So if we take a random example, such as calcium hydroxide reacting with H2SO4, look at what role the CaOH2 plays. So there's quite a lot going on at this point, so the easiest way to tackle this is to turn it into an ionic equation so you can see exactly what is actually being produced. So let's now look at calcium hydroxide. We'll react that with H2SO4, and we're going to convert everything that's aqueous into ions, and we'll also look at any other physical states being left alone. So let's turn that into an equation. So adding everything up, you can see that the water gets left alone, and the spectator ions are the calcium and the sulfates. We get rid of them, and that gives us 2 hydroxides and 2 hydrogen ions giving 2 waters. But this can be simplified further into 1 hydroxide ion and 1 hydrogen ion giving 1 water, which is a neutralisation reaction. So let's have a look at another one. This time the calcium oxide is a solid, so it's added to H2SO4, and therefore the calcium oxide and the water get left alone. So it's only the H2SO4 and the CaSO4 that get turned into their respective ions. So again, you can add in the calcium hydroxide and the water, and add everything up on the left-hand side, add everything up on the right-hand side, and write an arrow in between to turn it into an equation. So if you look at it closely, you can see that the only thing that can be cancelled is the sulfate ion. So we cancel that out on both sides, and that gives us calcium oxide as a solid reacting with 2H+, giving you Ca2+, and H2O. not forgetting our state symbols, of course. So let's try another one. This time we have calcium carbonate, and it's given to us as aqueous. So some might say that calcium carbonate is actually not that soluble in water. So what would happen is you'd be given the state symbols to work with, because they're interested in finding out if you can construct an ionic equation using the two steps on the screen, not somehow remember a list in your head of what's aqueous and what's not aqueous at room temperature. So in this case, we just put the ions in. We don't have to go through the rigmarole of actually drawing them out as a big long equation, because we've done that a couple of times already, so we can shortcut this a little bit. Get rid of the spectator ions on both sides to give us the simplest ionic equation for the neutralisation using a carbonate and an acid. So to wrap this video up, I just want to quickly have a quick look at ammonia. So ammonia behaves in a slightly different way to other bases. So I've just realised I said quickly have a quick look. I'm not sure what other way there is to have a quick look, but never mind. Ammonia is slightly different to other bases because it doesn't just dissolve in water, it actually reacts with it. So if you bubble ammonia gas through water, it forms ammonium ions and hydroxide ions. So we call it ammonium hydroxide. But in reality, here's what's happening. So I suppose really what we should say is the simplest ionic equation is something like that. So it follows on from that if ammonia produces aqueous OH minus ions when it comes into contact with water, it can therefore be considered an alkali. Okay, so this takes us to the end of this clip. I hope it's been a useful roundup of some of the stuff that you need to know for your first year, and if you're looking at it from a second year perspective, it's been a useful review of the stuff you learned last year. So once again, thanks for listening, and until next time, see you soon.